I am going to have a quick rapid fire of 3 new projects. This first project is circling back to what Fred mentioned in his talk earlier today, is that it's really, well, it was yesterday actually, which is really difficult to understand which model will work best in different corners of the continent. So this is a collaboration with Ying Fan, who's at Rutgers University, Hilary McMillan at San Diego State University, Katie Van Werkhoven, and then we've got a large community engagement piece that's in collaboration with Jordan Reed and the rest of Quasi. The background is that the premise for the next-gen framework is that a single model will not work well everywhere. And it's got the flexibility for users to configure models as a heterogeneous mosaic of alternative algorithms that might faithfully represent the dominant processes across different parts of the modeling domain. The rationale is that we don't really understand the spatial variability of hydrological processes across large domains, and we need to gain this understanding if we're going to provide some theoretical support for future instantiations of the future operational versions of the national water model that may be based on the next generation water resources modeling framework. So our methods are to first conduct a synthesis of dominant processes under different combinations of climate, terrain, and human forcing. So effectively, we've got hydroclimate from the top, topography and geology from the bottom, and vegetation, land use, and water management in the middle. And we're going to start with a clustering approach to try and identify distinct hydrological landscapes across the continent. Based on those landscapes, we'll identify initial perceptual models in each of those landscapes. So the perceptual model is our understanding of how the processes work. And we'll have box and arrow diagrams showing the processes that are dominant and how we can describe those processes in models. And then we'll have a series of workshops at regional scale. So we'll be collaborating with Quasi, and we'll be diving into each of these hydrological landscapes and working with the field scientists to see, well, okay, does the landscape make sense? No, it should be 2 landscapes. Does the perceptual model make sense? No, it needs to be refined in this way. And then circle back and provide a synthesis of the perceptual models across the continent. So the product from this research will be a hydrological mosaic where each landscape in the mosaic is described by a set of perceptual and conceptual models. How this feeds back into next-gen is it could be as simple as what Fred was talking, where we've got a drop-down box. You click on a piece of the hydrofabric, and it says, well, this is these are the model structures that could be supported in this corner of the continent. Yep, I've got 2 more. The second project that we're working on is for the Yukon River Basin. So coming from Canada, we were looking at where some of the synergies were with some of the other components of the CIROH consortium. And a key synergy was in cold region hydrological processes. So how can we work together to improve the representation of cold region hydrological processes in the next-gen system? So this is in collaboration with the PIs, Eric Anderson, who's at the Colorado School of Mines, and Mukesh Kumar, who's at the University of Alabama. The background, as we mentioned in the previous talk, is that NextGen's got the capability to combine process algorithms from different modeling groups and improve the fidelity of hydrological process representations at diverse hydrological landscapes. So what we're trying to do is leverage the expertise in cold region hydrology in both Canada and the USA to have new process modules that are included within NextGen and provide a better representation of cold region hydrological processes. We're focusing on the Yukon because that's a really important transboundary basin, and then it enables us to bring in the Alaska Pacific River Forecast Center, who are partners in this, and improve a lot of the applications there. So the processes that we're interested in include blowing snow, glacier mass, and energy balance. One of the partners on our project is Ashley Van Busekom, who's working with us. She developed the PRMS glacier model, so she's working there. Infiltration, water retention and transmission in partially frozen soil, permafrost freeze thaw, river temperature ice jamming, ice freeze breakup. That's primarily with Karl-Erik Lindenschmidt and Eric Anderson and floodplain inundation. And then we're also like stepping back and trying to improve methods within the broader next-gen prediction ecosystem, including methods for estimating spatial meteorological fields. Done a lot of work in Alaska and the Yukon on that before, ensemble data assimilation and large domain parameter estimation. And the expected impact is to improve future operational instantiations of the National Water Model in cold regions. And the third, and this is an interesting one, this also includes a consortium of universities across the continent. This is trying to understand the multi-model mosaic paradigm that underpins the next generation water resources modeling framework. So it includes Andy Wood from Colorado School of Mines, Mukesh Kumar again from University of Alabama, Katie van Werkhoven from RTI, and Xiaoping Shen. The rationale here, as we mentioned before, is the next-gen framework uses a mosaic of multiple models to represent the diversity of hydrological processes across large domains. The key is that the use of multi-model mosaics is a new paradigm for hydrological modeling. It makes sense where we can say it's naive to think that a single model will work well everywhere, and it's naive to think that a single model will be best at everything. But how do you actually take that and use it in earnest for operational hydrological prediction? What are some of the limitations there? And how can we understand those limitations and then begin to identify solutions for the operational implementation of the multimodal mosaic paradigm? So a part of this is to have more of a objective way to complement the perceptual model framework, which was primarily qualitative, to identify suitable modeling approaches in different parts of the domain. Develop methods to estimate parameters for the multi-model mosaic. So how do you estimate parameters in a model where you've got different model structures that are working in different parts of the model domain? And do we need to unify what the parameter definitions are? How can we do that? What are some of the challenges there? And how can we document the scientific validity and operational feasibility of alternative configurations of the multi-model mosaic? There can be some configurations that could be simpler to implement, which could be ensemble based, where you're just assigning weights to different models of the ensemble. They may have lower operational feasibility. There can be other methods where we're working with a deterministic multi-model mosaic, and how can we actually implement that in a realistic way? And the outcome is to try and identify effective operational instantiations for future versions of the National Water Model. So then there, thanks.
Hello, my name is Ping Shuai from Utah State University. So this is a USGS funded project, and I'm collaborating with Enric Triana from RTI International to advance water management, hydrological model coupling, and improve hydrologic forecasting. So the motivation of this project is the current hydrofabric does not have the water management infrastructure that's needed for water management modeling. And the goal of this project is to provide a roadmap for extending the hydrofabric to support the coupling of water management and hydrological modeling in management watersheds. So this is a proof of concept study, and we'll do this in a few selected watersheds within the USGS NGWAS study sites. And we'll also test the extension of the hydrofabric by coupling water management model with the USGS enterprise capacity model, with a hope to come up with an approach to extend the hydrofabric across canals and test the coupling with the water management models and hydrological models to improve the hydrologic forecasting. Thanks.
Dr. Bangalore is teaching, so he asked me to fill in for him. He's the PI on this project. The CIROH rock is the center of this. The idea is that we'll have a data stream of water flowing from the CIROH rock, if you get the analogy. The we've gathered computational resources, and we'll be expanding and growing that resource and inviting collaborative case studies. We'll post a URL on the Slack for you to put your idea out there, and we would like to help you take your project and make it connect with other projects by bringing it into a shared computational resource. And they have got some of the ideas that we've already started to explore here, and some of the others that we've begun to explore and brainstorm with the groups here during this meeting. In fact, so that's the whole concept. Come join us on the rock.
Good morning, everyone. As you have seen in many of these presentations, the main focus of much of the CIROH research has been on extreme precipitation and flood events. However, low flow conditions corresponding to extended dry periods can also be critical for operations, including municipal water supply. The objective of our project, which is funded by both NOAA and the USGS, is to develop machine learning tools to accurately predict baseflow conditions in U.S. streams. To do this, we are developing a Python library for digital baseflow separation techniques. We are also going to leverage Google BigQuery, which is currently hosting all USGS stream gauge data and retrospective National Water Model forecast, totaling over 100 billion records. We are going to analyze the stream gauge data to identify periods that we believe correspond to baseflow only. We will then use remote sensing data and in situ groundwater level measurements and other data sources as features to try to develop a machine learning model to predict baseflow at these measurement times and locations. And our long-term goal is to develop something that can be integrated into NextGen to predict baseflow at regions where this proves to be accurate. Thank you.
So we do have a late entry without slides, so 1 minute, please.
My name is Ximin Kai from University of Illinois, Urbana-Champaign. I apologize, I did not prepare slides. So you can relax, but allow me to talk a few minutes about my two projects. So many of us are working on national water model. We try to move from research to operation, but to have more realistic stream flow forecast, in many cases, we have to consider about the human interference. So among the interference, dam or reservoir regulation is an important one. So my two projects are both related to the reservoir operation. So you heard about CIROH, forecast informed reservoir operation. So our first project is to use CIROH to analyze drought impact on water supply at a river basin scale. So we try to combine S2S forecast, stream flow simulation, reservoir regulation, and water supply system simulation. And eventually we'll look at how the S2S forecast could mitigate the drought damage. And we also look at the interaction between stream flow and the reservoir regulation in terms of drought impact. All right, so this is a USGS project. The second project is funded by NOAA. And so this project follows the existing ERDC research on CIROH. ERDC has conducted a few pilot projects on CIROH in California. And our project is to look at how we could improve it based on, through interdisciplinary team. So we have two reservoir modelers from water resource systems community, myself, and also my colleague Irfan coherent. So we try to bring like 20-year research, maybe 30-year research on reservoir operation into this framework. And we also have our engineer. Looks like okay, nice. And our second person, he's a real-world water resources engineer. He has a lot of experience to communicate between researchers and the real-world reservoir managers. And our third co-PI is an economist. That's George Van Hoven. He presented yesterday. So altogether, we try to look at what kind of economic valuation could forecast bring to flooding control as well as the water supply in the post flooding season. Thank you very much.